there are a couple variations on the idea of a limit that involve infinity. So for one example, let's look at the limit as x goes to 2 of 1 over x minus 2 squared. And here's a graph of that function. So we are keeping an eye on 2 since x is approaching 2. So let's do what we usually do. We can start to the left of 2 and slide to the right. So that's the point on the graph starts here and goes this way. And then if we start to the right of 2 and slide to the left, then it's going to go like the point on the graph goes like this. So what height is the graph heading towards as we get close to x equals 2? Well, there's no finite height that this graph is heading towards, but there's a clear sense in which this graph is heading off to infinity, right? The closer you get to 2, the higher this graph gets on both sides of 2. And so it probably makes sense to say that this limit is plus infinity. And that is what we'll do. So it is fair to call this limit plus infinity, but we will have to keep in mind that although this limit is infinity, it's not a finite number. Usually when we're asking if a limit exists or not, we really mean is the limit a finite limit or not. So, a limit being infinity isn't quite the same as the limit existing as a finite number. But there's a clear sense from the graph that, this limit is plus infinity. We do have to be a little careful with the limit being infinity because let's look at, for example, 1 over x. So let's find the limit as x goes to 0 of 1 over x. Now if you just think about this graph in general, well, when x gets small, 1 over x gets big, so shouldn't this be infinity? Well, let's look at a graph. 1 over x looks like this. If we start to the right of 0 and head towards the left, the graph goes up. If we start to the left of 0 and head to the right, the graph doesn't go up, it goes down. So it goes down towards minus infinity, but it's not going in the same way as it is on the right. And so this limit, well, the two sides don't agree. And so this limit actually we shouldn't say that this limit is infinity. We should say it doesn't exist because it goes to infinity, plus infinity from the right, but not from the left. All right, you can see that didn't happen in this first example because this squared here makes it so that the graph goes up on both sides. All right, another variation on infinity appearing in limits is we could use infinity as the value that we're heading towards. Now this is a very concrete example where our x value never actually reaches our value for a because, a real variable can't be equal to infinity since infinity isn't a real number. So how should we interpret a limit as x goes to infinity? Well, how we should interpret this is just, right, we can't approach infinity from above, so we'll approach infinity from below. Start with our x value below infinity, the corresponding point on the graph is here, and then slide our x value out towards infinity. The corresponding point on the graph is going to slide this way, and then we can ask, what height is this graph approaching? Well, for this graph, it's pretty clearly 3. Okay, so this kind of limit where infinity is where you are taking the limit, this is called a limit at infinity. Another variation on this same idea is we could have something like, I don't know, how about just x squared. We could ask, what is the limit at minus infinity? What's the limit as x goes to minus infinity of f of x? Well, we can't approach minus infinity from below, so we have to approach it from above. So let's put our x value here somewhere, and then slide x out towards negative infinity. What happens to the corresponding point on the graph? Well, it just keeps going up and up and up, and so this limit ought to be plus infinity. So here's a limit at minus infinity that is an infinite limit.